Hi everyone, in this video we're going to look at first hop redundancy protocol. First hop redundancy protocol is a category of networking protocols designed to provide redundancy for the default gateway in a subnetwork. So this is a key component for network resiliency inside a particular network design. So this protocols allows for us to add redundant devices such as layer 2 switches or layer 3 routers into a topology. Let's look at this example topology where we have on the left hand two routers acting as the gateway, where both routers 172.16.1.2 and 172.16.1.3 can be the gateway for this PC. This topology is also the same, but basically using a multi-layer switch. So this topology shows an example of adding redundancy. That means we add an extra device as a backup or as a load balancer to perform the same task. So without any first hop redundancy protocol, this PC, when it has two devices acting as the default gateway, it would have to keep on changing the default gateway IP address. But with the use of the Fhrp, you don't need to configure multiple gateways because the Fhrp allows you to automatically change between the two default gateways. So there are three protocols in the family of FHRPs, namely Hot Standby Router Protocol or HSRP, Virtual Router Redundancy Protocol or VRRP, and Gateway Load Balancing Protocol or GLBP. So there is one feature in FHRP called object tracking. So this feature helps routers monitor the status of specific network elements, for example, interfaces, other routers, or some IP addresses, so that they can make more strategic decisions about a failover. So this seamlessly links the router's FHRP configuration with other routing components. So in order for us to configure the object tracking, use the keyword track, and then we give an object number. So in this example, it's trying to track the routing table. So we use the keyword IP route and a particular route or a prefix network. So for example, here the network is 192.168.3.3, and then the prefix is 255.255.255.255, which means it's /32. And then the reachability is the object element's particular status. So if for IP route, we want to check the status of whether that particular network is reachable. And then we can verify this command by using the command show track with the object number. Or if you want to view all of the object tracking, you can just use the show track command. This is another example of using the object tracking. In this example, we are tracking an interface. So again, we can use the keyword track and then the object number. In this example, the object number is 2. And then we are tracking an interface. So we specify the keyword interface and the exact interface that we are tracking, as well as the status of that object. In this case, the status of the line protocol. To see whether this object tracking is working, since it's an interface, we can test by shutting down that particular interface that we are tracking. So in example 15.7, we shut down the interface gigabit Ethernet 0/1. So the line protocol changes its status from up to down. So since we are tracking it, so there is a log here, track 6 state 1 IP route, that particular network, and reachability is down. So that was for the object tracking number 1. So since the protocol is down, the IP route is also unreachable via that particular interface. So this object tracking feature works with all three of the protocols in Fhrp. Let's look at the first protocol in Fhrp, which is the HSRP or Hot Standby Router Protocol. So HSRP is a Cisco proprietary protocol and provides routing redundancy for hosts configured with a default gateway IP address. In HSRP, a minimum of 2 devices are required. One device acts as the active device, and it will be doing the forwarding of the packets while it is active. The other will be the standby router, and as the name states, it will be the standby router, only taking operation if the first or the active router has a problem or fails. So since the main point for Fhrp is the configuration of one single default gateway, although we have physically 2 or more, so in HSRP, we have a virtual IP address that we configure on each of the routers, so that the machines or the PCs will get only one default gateway IP, and that is the virtual IP address. So the related MAC address will also be a virtual one. So this MAC address will relate to the virtual IP address. So then, in a normal operation, the router that is active will be forwarding the packets when a PC forwards the packets from itself to the virtual MAC address. So in order for the routers in the same HSRP group to communicate, HSRP uses a multicast UDP hello message. So this hello message is used to detect any failure and also designate the active and standby routers. So through the hello message, they can detect the active router if it fails. So after this active router fails, the HSRP standby router will automatically resume the operation of forwarding packets. So the HSRP active and standby routers happen by looking at the priority. So it will select the router with the highest priority. By default, all routers will have the priority of 100. So in this case, if there is a tie, the router with the highest IP address will be selected. So there is a concept of preemption. So by default, HSRP does not support preemption. So that means if at first a router with a lower priority has become active, then another router that has a higher priority joins the network in the HSRP group, it will not automatically become the active router. So the router that has become the active router and has the lower priority, it will stay the active router unless you configure it to be otherwise. So currently there are 2 versions of HSRP, and the later version is not backward compatible with the earlier version. So the difference between the two is one in terms of timers. HSRP1 does not support millisecond timer value. So that means you can only modify the timers in values of seconds. So that means it is less granular control of the timer compared to HSRP v2, which does support millisecond timer. So you can configure the timers in the values or in the range of millisecond. The next difference is in terms of the group range, where HSRP v2 has a more expensive group number. Then the multicast addresses are also different, where HSRP1 is 224.0.0.2, while HSRP v2 is 102. And the way that you configure the virtual MAC address is different in HSRP v1 as opposed to HSRP v2. HSRP v1 has the MAC address format where the last 2 hexadigit, it depends on what group number that you have configured on the router. Okay, let's look at the steps for configuring HSRP virtual IP address. First, you will need to define the HSRP instance the keyword is standby, and then you give an instance ID. So this is the group number that we were talking about in the previous slide. All right, and then you give the virtual IP first with the keyword IP, and then the virtual IP address. So next, this is an optional step. By default, HSRP does not support preemption, but you can change that with the command standby, and then the instance ID, and then the keyword preempt. So in this case, the router that you configure to have preemption, if it becomes failed, and then the minute that it becomes active again, or it becomes operational again, if it has the highest priority among the routers in the group, it will automatically become the active router. In the next step, you can configure or modify the priority value of the HSRP routers. The default value is 100, but if you want to make sure that one router becomes the active router more than the other routers, you can modify the value of the priority by using the keyword priority, and the value can be between 0 and 255. Next, by default, HSRP will take on the format of the virtual MAC address according to which version that it is. You've seen the format of the MAC address in the slide before, but you can also modify this into a more memorable MAC address. For example, in your own topology, you have some kind of convention, then you can change the MAC address number by using the command MAC address, and then the actual MAC address that you want to configure for the virtual MAC address. Next, you can also modify the timers. So the timers are for the hello timers and also the whole timers. Like I said, it depends on which version that you configure. If for HSRP version 1, it only supports timers in the values of seconds. On the other hand, for HSRP version 2, you can modify the timers into the range of milliseconds. So this range can go to up to 999 milliseconds for HSRP v2. You can also set authentication for the HSRP routers. So you use an authentication password. And also, if you need to encrypt using MD5, you provide them with a keychain and keystring. So this is a basic HSRP configuration example. This configuration was done on the interface VLAN 10. So we configure the virtual IP address as 172.16.10.1. The actual virtual interface address is 172.16.10.2, and the standby group number or group ID is 10. And then we configure it for preemption by using the word preempt. To verify the configuration, we use the command show standby brief. So the output on switch 2 indicates that it is a standby router for this group, number 10, or it represents the HSRP group for VLAN 10. And the active router is on switch 3. Now we can incorporate object tracking inside HSRP. As we've seen the command before, the keyword is track, and then the object ID, and what is the object that we are tracking. In this example, we are tracking the interface VLAN 1 and the status of the line protocol. So if the line protocol status of interface VLAN 1 changes, then the action to do is to decrement the priority of standby group 10 by 20. So to test whether the object tracking works, we shut down interface VLAN 1. So when it goes down by right, it should decrement the priority of interface VLAN 10. So here it shows that it is working, because when we decrement the priority, it automatically becomes from the active to standby. Next, let's look at the second protocol in Fhrp, which is VRRP or Virtual Router Redundancy Protocol. So compared to HSRP, this is an open standard. So it's suitable for all other vendors. In VRRP, instead of calling the operating router as active, we call it as master. And the other routers, instead of calling it standby, we call the routers as backup. Unlike HSRP, which it doesn't support preemption by default, VRRP does enable preemption by default. For VRRP, the virtual MAC address is in that format, 0000 5E0001 and XX, where XX reflects the group ID in hexadecimal. So VRRP supports two versions, which is version 2 for IPv4 and version 3 for both IPv4 and IPv6. This is the example of a legacy VRRP configuration. So it's quite similar to HSRP, where you have the keyword VRRP instead of standby. And then the group ID in this example is 20. And then the virtual IP address, which is 172.16.20.1. You can also configure the priority by using the keyword priority. You can do also object tracking in VRRP by having the keyword track the object ID. And then the action, for example, you can decrement some values such as priority. VRRP also supports authentication. So to verify the configuration, we use the command show VRRP brief. This is as compared to HSRP, which uses show standby brief. So for the command that has the keyword brief, you will show the status of each interface and the priority and whether it's a backup or a master. If you just use the show VRRP command, it will have a little bit more detail. For example, the advertisement interval and the down interval. So a newer version of VRRP now exists. So this is called hierarchical VRRP. So basically it's in the version v3. So first you need to change the version to VRRP v3. So since it supports both IPv4 and IPv6, you need to define the address family. So the command is VRRP instance ID address family, and then you specify whether this VRRP instance is for IPv4 or IPv6. That means you can create instances of VRRP in both IPv4 and IPv6 using the same set of configuration. You do not need to configure multiple times. Bear in mind that if one router uses VRRP version 3, then all other routers need to be changed to version 3 as well because they are not backward compatible. So once you are in the address family, for example, here the example is VRRP group ID, which is 22, and the address family is IPv4. Now you do not need to define the keyword. You only need to put the address 172.16.22.1 because you are already defining the IP inside the family IPv4. Then the other keywords as well, since you are already in the VRRP mode. So you just enter the keyword track, priority, and so on. The third protocol in the family of first hop redundancy protocol is called Global Load Balancing Protocol or GLBP. As the name implies, it also supports a load balancing. So when we have load balancing, that means we can have the routers all operating together at the same time. So there needs to be somebody that coordinates the forwarding of packets. So this we call the active virtual gateway. So this AVG will become the active router that responds to the initial ARP request for the virtual IP address. And then all the other routers will be the active virtual forwarders. So all the routers involved in the global load balancing protocol, for example, there is more than two, they will get the same virtual MAC address that is in relationship to the virtual IP. So GLBP supports four active virtual forwarders and one AVG per GLBP group. So a router can be an AVG and also an AVF at the same time. And we can appoint a standby AVG device as well, so that when the active AVG router fails, there is a backup. So again, the configuration commands are quite similar to HSRP. Instead of using the standby keyword, we use GLBP, the group ID, and then the virtual IP address. And then we can also configure for preemption. We can also modify the priority value and the timers, as well as authentication mechanisms. To verify, again, we can use the show commands. One is show GLBP, the other is show GLBP brief. So since the difference between HSRP, VRRP, and GLBP is made especially for load balancing. There are three methods of GLBP for load balancing. The first one is round robin. So as the name implies, each AVF will take turns in forwarding the packet or replying to the request for the virtual IP address. So this is the default load balancing method. Next one is called weighted. So like the name implies as well, we can assign weights to each of the AVF to define which router gets the priority of forwarding. So the routers that are more powerful or can handle more traffic will be assigned a larger weight. The third method is called host dependent. So it uses the host MAC address to decide to which virtual forwarder MAC to redirect the packet. So this method ensures that the host uses the same virtual MAC address as long as the number of virtual forwarders does not change within the group. So the command to change between the three methods is keyword GLBP, the group or instance ID, load balancing keyword, and then you define which method that you want. By default, again, is round robin. So for the weighted method, you need to define the weight by using the keyword weighting and then the weight. Here's an example of GLBP where the load balancing method is weighted. You can verify the method of load balancing by using the show GLBP commands.